guys, I hope you are okay, doing well. Today we're gonna be talking about synoptic weather map. I'm not sure if you are familiar with the topic or anything, but before we do anything, I would like us to watch a video for 2 minutes or less, and then we'll take it from there. Before you're watching a video, you're gonna tell me what you have learned from it, as well as any questions if you have them.
And some of you will understand what the lines and the triangles, the different bits and pieces, wind speed, direction, currently, and also see how they evolve. Let me take a look at this map of the UK and the North Atlantic. You can see the pressure pattern there. That'll be a familiar sight for many of you. It's important to know that pressure, wind, and temperature are in constant balance throughout the atmosphere, but the atmosphere is always changing to try and maintain that balance. And for us in the UK, things are particularly changeable, and we tend to see quite variable weather as a result. Now, the pressure pattern will always show you a number of things. We'll always have areas of high pressure and areas of low pressure. And these white lines that circulate around show where the pressure is equal. They're called isobars. Now, air moves from areas of high pressure to areas of low pressure to try and maintain that balance, or to try and ease that difference. And that's when we have air moving around and we feel wind moving. Sometimes, though, the pressure gradient, if you like, the difference between the high and the low pressure is much bigger, and so the air moves faster, and that's shown by tighter isobars that you can see to the north of the chart there. So we know something about the speed of the wind, but what about where it's coming from? Well, we know that air moves around areas of high pressure in a clockwise direction and in low pressure in an anti-clockwise direction. So now we know something about the speed of the wind and indeed where it's coming from. Now, these differences in pressure, temperature and wind circulating around the globe mean there's different types of air, and by that I mean...
Thank you. From the video that we have just watched, what did you hear or what did you learn?
We learn about Synoptic weather chart and what is it. Refers to the summary of weather conditions over a large area at specific area.
I think also touched the definition of synoptic weather map. Again, is there anyone who learned anything?
The video was about teaching us about how to interpret the synoptic weather map.
All their answers were accurate and exactly what I was expecting from you. And then we're proceeding, as you said, a synoptic weather map refers to a summary of a condition over a large area at a specific time. And then we're gonna learn about isobars. Isobars are those lines that, when we're talking about isobars, we're talking about these lines over here. These lines are called the isobars. So you'll find them in every synoptic weather map. When we're talking about isobars, we are talking about patterns of high plate. They include high pressure and low pressure cells, and it is the distance gradient between those two lines. So if the gradients, the isobars, those isobars are closely packed, it means that the gradient is steep. And then if those isobars are far away from one another, it means that the gradient is not steep. And if it is not steep, it means that the gradient is gentle. And then when we come into another thing about the synoptic weather map, we have different weather conditions. And those weather conditions differs based on what you will have to learn about them. So let me just quickly show you what I'm talking about. As you can see there, we have the first thing we have is a maximum temperature, because it is always higher than the one that is below. And the one that is below is the dew point temperature, which can also be called the minimum because it's lower than the one on top. The following thing is we have the wind direction. So when it comes to wind direction, it means that you have to know the directions, and then you have to know which direction it is that is on your question. Another thing, we have the wind speed. Wind speed is calculated in knots. So if the tail here is short, it means that it's 5 knots. If the tail is long, it's 10 knots. So if it's two tail, the one is big and the one is short, it means that it's 15 knots. When we come here on the cloud cover, then you have to know if there's nothing, it's not shaded, it's clear. If it's not shaded and there's a line in between, it's half, then quarter, full, overcast, depending on how it's shaded, or if it's shaded or it's not shaded. And then when we continue, we have the precipitation. The precipitation, you have to know if it's either it's raining, it's drizzling, it's showering, it's snow or hail. This has to depend. You have to know these symbols so that you won't be confused when you see them on your exams or any test that you might be given. Then before we continue, we can go back to the temperature. When you write this different weather condition, don't forget to include their unit of measurement. So if it's a temperature, it means in degrees Celsius, just like that. Even the dew point, you have to use the Celsius. Don't forget to include those measurements because they are also so crucial. You can't just write 23. You don't know if it's 23 degrees, 23 what. You have to include them as part of your work. And then we come here. There is a difference between the low pressure and the high pressure. As a student, you have to know how many high pressures we have, where they are situated, and the condition that follows with them. You have to know all the high pressures in there. There's a high pressure that is situated this side, and the other one is situated this side, and the one is in the interior of South Africa. The one that is here is the Kalahari high pressure cell, and then the one that is this side is the South Indian high pressure cell, and then the South Atlantic high pressure cell. Then you have to be familiar with the high pressure cells and the condition that comes with them. The high pressure cell is where in the air it descends and it will be moving in an anti-clockwise direction, and the low pressure cell, the air rises and it moves into the clockwise direction. Am I making sense?
Yes,
ma'am. Okay. And then if I'm making sense, we have an activity that we have to do. It's not that long. I think it's 2 to 3 questions. Then after that, I will get to know if you really understood the content that I was teaching. Please quickly take out your books and then write the following activities. I'm only giving you 2 minutes. I hope we are all done. Okay, the first question is define the concept synoptic weather map. Here you are expected to explain this term. Can any one of you tell me what is a synoptic weather map? Okay.
It's a map that displays the weather condition in a specific region or area.
Correct. Is there anyone who wrote a different thing? Oh, it means we both wrote the correct thing. What are the black lines on a synoptic weather map called? Isobars. Anyone who wrote a different thing? Then we're good. Is the air pressure at B a high pressure cell or a low pressure cell? Give a reason for your answer. Air pressure at B. Here is B. Is it a low or a high pressure? It's a low pressure, and then give a reason for your answer.
Is the coastal is what is the low pressure that causes coastal low because we found it on the coastal areas.
Okay, that is also correct. So it means every one of you got everything right. Then it means that you understood. And I hope I've managed to reach my lesson objective because you are able to explain the synoptic weather map. You know the difference between the high and the low pressure cell. Is there anyone who has a question? Okay, the class is adjourned. Then I'll see you tomorrow. Thank you.